This is for sketching logarithmic graphs. The general shape of y equals log base e of x will be a graph that has an asymptote at x equals 0 and will shoot like this with an x-intercept of 1. No matter what the base is, as long as the base is bigger than 1. Okay, so keeping that in mind, that that's my general shape of a logarithm, then what's happening in this case here is we have a reflection and we're replacing x with negative x. So my graph is going to shoot this way, and then they've got some sort of sideways move. I will have my asymptote at this equaling 0. So 1 minus x equals 0 will give you your asymptote. So 1 equals x. So I've got an asymptote at x equals 1. So I'm going to have my asymptote here at x equals 1. I suspect since that there was 1, that would be negative 1. When I move to the right one, I'm going to go through a 0, 0. But let's just double check that. So y of 0 will be equal to log base e of 1 minus 1, 1 minus 0, which is log base e of 1, which is 0. So that's correct. My graph looks something like this. And I need a second point because I've got 0, 0. So I'm going to choose negative 1. So y of negative 1 will equal log base e of 1 minus minus 1, or log base e of 2. And there's my graph, asymptote, 2 points labelled, and there's my curve. Looking at question 2, I can see a couple of things are happening. We have a negative here, which means we have a reflection over the x, and we have a positive there, but we have some sort of movement happening. So instead of looking like this, it's going to look like this. Okay, so 2x minus 3 equals 0 will give you your asymptote. 2x equals 3, x equals 3 on 2. So at y equals 3 on, x equals 3 on 2. And we're going to shoot somehow like this. So I might put my graph in like this. And to find the x-intercept, set that equal to 0. 0 equals negative 2, log base e of 2x minus 3. Divide by 0 equals log base e of 2x minus 3. 2x minus 3 equals e to the 0. 2x minus 3 equals 1. 2x equals 4. X equals 2. So that gave me a nice value of 2. I'd like to find another point. I might choose 3, and y of 3 will equal negative 2 log base e of 6 minus 3, or 3. So 3 and negative 2 log base e of 3. And there's my graph. I've got my asymptote, I've got my y-axis, I've got my x-axis, and I have 2 points labelled. Looking at question number 3, I can say I have a reflection over the x and I have a reflection over the y. 4 minus x equals 0, x equals 4 is where my asymptote is. But my normal graph that looks like this, reflected over the x-axis, would then look like this. Reflected over the y-axis will now look like this. So this is going to be my general shape. So I can draw my axis. I can put my x equals 4 as being my asymptote, and my graph's going to look something like this. I'd like to find the y-intercept. Y of 0 will be negative 3 log base e of 4 minus 2. Definitely going to be a big negative number because this negative 3 log base e of 4 is bigger than 1, so that's going to be bigger than negative 3, and then we're going to minus 2 from it. The examiners like you to simplify. Whenever you've got a perfect square in here, change this to -3 log base e of 2 squared minus 2. Then the 2 can come down, -6 log base e of 2 minus 2. So I'm going to put this as being -6 log base e of 2 minus 2. And my graph's going to look something like that graph approaching this asymptote. And I need to find the x-intercept. The x-intercept is when -3 log base e of 4 minus x minus 2 equals 0. So log base e of 4 minus x equals minus 2/3, and that 4 minus x equals e to the minus 2/3, and negative x equals e to the minus 2/3 minus 4, which means x equals 4 minus e to the minus 2/3. So I'm going to put that there and say 4 minus e to the minus 2/3 and 0. And there's my x-intercept, there's my y-intercept, and there's my general shape. And I've worked out the general shape based on the reflections. So there's your sketching of logarithms.